Hello, thanks to everybody for showing up in such large number. My name is Kosta Pribic. I've been working in telecom for about 7 years, and I was lucky enough to start working in a service and platform development department from day one. So after about a year or so, I became a technical lead for one quite big project, which involved taking an existing large architecture for business voice and completely migrating it to a new platform end-to-end. Everything had to be done from scratch, from provisioning phones, integration, all functional stuff, everything. And while doing that project, a new initiative started in my company that had the basic idea of improving security of all projects. They assigned a contact person from security, and they did an evaluation along with us on what should be done in one way or the other with consequences for security. And this was one huge Excel spreadsheet that had like 40 tabs. It took 3 weeks just to negotiate everything in that sheet, and for the next project I did, the same vendor actually budgeted 3 weeks and 3 full-time employees for the next time we do something like that. And the bad part with that spreadsheet was that it was hardening, nothing else. It wasn't security in a sense that you should design a system in such a way that it can be manageable and resilient in some way to intrusions or instabilities in the network. It was just hardening in a sense that they asked you what was the password on this. Is your machine of one level of security on the same virtualizing infrastructure as a machine with a different level of security? Or do you have the latest patches and so on? So it was a general document, and my attempt at this talk is to try to give some hints on how to design specifically telecom voice in such a way that it's manageable and resilient. This is not something covered by typical spreadsheets on security because they are inherently general, because they have to cover lots of different architectures and systems. So to understand why this is such a big issue, we need to go a bit into history. I promise not too much. In telecoms, you have NT and IT. NT is a specific world. NT does voice. NT is responsible for your phone to work. NT is responsible for emergency services to be reachable and so on. And they are closed down, proprietary. Everything has to be high availability, everything. And it's slow to change, and standards are quite stable. IT, which I presume you're more familiar with, is different. You get standard hardware, you get standards that change as quickly as possible, and you typically do not have to cover 5 nines. I don't say you don't have to cover it anywhere, but most of the systems don't require 5 nines. And the problem is that now NT systems are starting to look like IT. This is a problem for NT, a big one, because people in NT are used to this. So this is how a telephone system looked 10 to 15 years ago. You had some proprietary system inside. There's no IP. Everything is ISDN. There's no DDoS. There's no HTML vulnerabilities. There's no Apache security issues. There's nothing. There's no attack vectors because it's quite closed. On the access side, the only thing you have to worry about if somebody has a PBX, that they send only the numbers they should be sending. And this is easy to enforce. You just say you have an ACL type of thing, where you say only these numbers are okay, nothing else is acceptable. And you're done as far as you're talking about security in the architecture. Fraud is another thing, we'll mention that a bit later. So let's go forward about 5 years, and you have this. Telco didn't change, but companies discovered IP, they discovered VoIP. You have Cisco system, asterisks, and so on. And as soon as they discovered that you can use IP, they also discovered that you can manage it remotely. You can open it to public internet. And as soon as this became a reality, there was a surge in fraud, because people from the internet just managed to compromise the PBXs, and they started calling and committing fraud. 5 years forward, This is what the network looked like. I started working on these systems about at this time. Now you have IP on the both sides. You have IP core on the telecom, and you have a link to the old system on the PSTN, and you have IP on the access. Nobody knew how risky this was. And to mitigate that risk, as you can see on the lower left side, there's a IPPBX with 2 voice gateways, and they have an ISDN link. This was a requirement from some banks. They didn't want to connect directly IP to IP because they couldn't they didn't know how risky it was and what could happen, and they said, no, only way we can talk is we have 1 meter of ISDN. That's safe. After a while, everybody pretty much went to the second variant, which is the customer number 2 on the slide, where you have an IP link directly, but you still have the security issue. And the security issue is supposed to be solved with a component in the yellow called SBC, Session Border Controller. SBC is where you would put almost all security devices you have at hand. SBCs can handle DDoS. They have a back-to-back user agent, which theoretically means they should be moderately resilient to fuzzing attacks. And you can do access segregation. They're really weird devices because they're kind of like routers, but they don't route IP. They route voice, which means they can be connected into overlapping address ranges. They can have a same network on both sides and route between them because they don't care. The network is contained on the interface and doesn't enter into the logic of the device. This makes for some very complicated architectures, and you really need that functionality. But this is the part that was not so much covered by standards. Standards covered something else. And this is according to the RFC 5853. This is SIP interoperability features, topology hiding, media management, and non-traversal. For security purposes, the most important one is the topology hiding, because SIP by definition assumes that you trust everybody. It's kind of like SS7. If you watched YouTube videos about vulnerabilities in the mobile networks, SIP basically says if you're peering with somebody, you just send them everything. And you need something to strip away all the confidential stuff, to strip away all the information about your core network, to strip away all the headers you use to implement some functionality which may not be covered by the standard. And this is difficult because you need to do it in real time. There are a bunch of headers in SIP which you need to remove in real time, and this gets to be quite CPU intensive per message. Not traversal is basically so that the stuff works over typical internet leaks which use NAT, and media management is interesting insofar that you can't cheat in such a way that you establish a call and then just end the call but continue sending media. So this guy gets that and cuts off the media. Now that we have some overview of SBCs, what does a relatively modern network look like? Well, something like this. As you notice, SBCs are everywhere. And you try to contain types of users on different SBCs because it's manageable that way. Assuming that you are not a telco expert, to give you an idea, how does one call look? So it's something like this. If you have, let's say, a residential user on the left, he tries to send an invite, it goes to the SBC, it goes to the telco core, it doesn't matter what it is, it's just some core, it's IMS, and then it's triggered to some sort of service server, in this case residential server, then goes back to the core, it's transited to whoever is the B side, in this case it's a VoIP user, and then it's propagated back to the access. Only security here are the SBCs. Yes, the core validates if you have a correct user and a password, but that's pretty much it. So if somebody tries to attack you and somebody tries to impair your service or bring down the whole network, you have to end it at the SBC. In order to be able to do that, you need to set up some rules. So the first rule you do is say, okay, you can register, but do you really need to register from anywhere? If you're a residential user, you're not going to be carrying your line with you where you go around. So a good idea is to limit that. So you try to limit anything you can as close as you can. And this is possible on telco networks because we own the access. We know where everything is, we know which type of device is where, and we can do something about it. One problem, one exception is when you have a big company that has its own network and you just peer with them, have a SIP trunk, and they pass calls along the locations using their internal network, then you basically have no idea where is what. You can have a company that has a small branch office on the other side of the country, but to you it looks like it's coming from their main site because everything is hidden. There's not much you can do there. So, how to lock down access? First idea is try to lock it down to geography, because when attacks come, they're usually not from everywhere at the same time. So, it's good to have some idea that it's geographically limited. The next point is to limit by device type. This is very useful. Actually, this is mandatory, because if you do not do that, you can't implement denial of service protection. For example, if you have one phone, denial of service protection works in such a way that it measures the number of SIP messages that's coming from one specific IP address. And what if you have more accounts on one IP address? There's no way for the SBC to know that. So, for example, if you have one IP phone, you have one protection profile, but if you have an MSAN, that's a special device that handles some 5,000 accounts for those people that don't have IP phones. If you do not separate them in the initial design, there's no way to cover them all with the same security policy. And you can't apply a different security policy unless they are separated in some way. Third type is the SIP trunk, as mentioned, for the large companies like banks and so on. You here have different rules because there's no registration. You implicitly trust them. So the only way to protect yourself is to rate limit based on history. So, or a contract, if you have a contract with them that says it should be only this many calls, then you do set parameters that only so many calls are possible. Why is this an issue? About 5 years ago, it wasn't set up all that well on one trunk, and I was complaining to my boss then, and she didn't really see why was that such an issue, because in her experience, if you put in an ISDN trunk, you're safe. Nobody can overload you. And I pretty much halted the SBC with 3 megabytes of traffic, which I generated with one text file and ncat command, nothing else. That was enough to bring down, I don't know, couple of million kunas of hardware. So good configuration is mandatory. Good configuration requires segregation. And it's also possible to segregate based on customer location, because if you have a customer that has multiple locations and you get an attack, you the customer is not the one attacking you. They had a breach and somebody is attacking you over them. So you probably do not want to lock everything that you can that's related to that customer. You want to segregate the damage so that it hurts as little as possible. All this is when you control the access. And all this is very nice, and then somebody from marketing says, but we want to allow people to make phone calls over public internet. And none of the stuff that I said, except device-specific locking, works over the public internet because you don't know where it's coming from. There are no rules. So how to have some sort of security in public internet? Well, first, the DDoS configuration I mentioned, make it really, really tight. No more than the minimum amount of messages per IP that's coming along. If then you get into a situation, somebody has a NAT and you know that you have multiple messages coming from there, maybe you can loosen it up a bit, but it would be ideal if you handle that NAT as a specific case. There are not that many companies that will have that much traffic that you need to worry about it. Use encryption. The odd thing is that when we put encryption on the public interface, the number of scanning tools that scanned it dropped off exponentially. So this basically means that people who do the scanning do not want to expend resources on establishing TLS sessions, and it's cheaper just to push out UDP packets, and you'll find something somewhere. It's a good idea to block scanning agents. So there are some 10 or 15 known scanning agents, and people usually don't bother to change the user agent, so you can simply block them by user agent. This works much better than I expected. So this reduced the traffic by 99%. Almost nobody tried to fake the user agents in such a way that it looks like a phone. It's trivial to do, but you don't have to do it because most people don't block this. And the fourth one is design. You really don't want to have the same device with access to the internet and with access to the critical stuff. For example, if you have 112 services, communication trunks for flight control or something, or hospitals and so on, so things that are really critical, you try to separate that as much as possible from the stuff that's exposed, because even though SBCs are built to be robust, they still break apart. You can assume that sooner or later it will fall apart. The most ridiculous case of failure I've seen is an SBC completely falling apart when somebody sent a SIP message and the field from was written F-R-O-H, so froh. The box fell apart. So those kinds of bugs happen, they will happen, and assume that whatever you expose will break because of a meaningless bug. It doesn't have to be a smart attack. These are very, very complicated devices that makes them susceptible to stupid bugs. And last part, so the last 4 points, is basically block everything, then allow as needed. It sounds like an obvious device, but it's actually hard to implement when your marketing is hounding you to allow, well, we want to allow this, allow that, and you have to negotiate. But this is very important and should be taken very, very seriously and enforced even at the cost of looking unreasonable, because later you will be sorry. If you're launching a local service that should work only in Croatia, there's no need to allow Chinese IP address ranges to connect to it. And if you really need to allow Chinese IP ranges, then somebody else needs to sign on that this is okay. That's a huge difference in risk. So these are the things that you need to think about in advance. This is not something you wish to discover later, because later it's too late. Somebody has to take responsibility for this in advance. So what does it look like to be connected? This is one example of a message that was unsolicited. It was an invite message that came on our public interface. This number, I think this is Israel. So this invite message is trying to solicit a call from us by sending an invite. This won't work on a telco network, but this might work if you have a publicly exposed PBX. And this might work if you have a telephone with a public IP. Yes, people do that. So this will probably convince a phone to establish a call to some number, and this will of course be charged to you. This is a slightly smarter option. So this is basically the same attacker from before. He first tried invites, and then he tried to do an SQL injection. So it's embedded in the contact field and in the from field. And again, this is not really a problem for telco core components or the SBCs, which drop this because it's an unsolicited invite. But you might imagine that if your PBX was exposed, would it handle something like this? And this is my favorite. So this is I particularly like the user agent. It says friendly scanner, just so you don't think it's he's trying to do something bad. So this message is trying to just find SIP-aware stacks on the internet. And a good idea is that if you have something like this, configure your SBC not to respond with an error, but to black hole the message. So when you get some message which has, for example, a user format which is not yours, just configure the routing on SBC to black hole it. That way, somebody who's scanning won't have a response, and you will be a smaller target. Now that was on general design on SBC, but what about fraud? This is something that telcos worry about. There are many fraud scenarios, but to cover two here. Basically, one is compromised SIP account, which is quite obvious. If somebody takes control of your SIP account, they're going to be calling in your name. The other one is compromised self-provisioning. So if you have a portal or something that can configure options or services on your account, somebody can establish many calls on your account and reroute them to some value-added service in Kenya or Israel or wherever, and you'll get charged for that. Now, the way to defend from this is obviously, to have a system that detects stuff like that. But one much easier way is to reduce the damage. So, for example, if you have an attack that is based on many sessions or one number, just limit the numbers of sessions you can have on that one number by default. So make it a system-wide default. This also goes for forwardings, for a number of calls per trunk, to calls for international destinations, and so on. So the idea basically is the same. You need to lock down everything and then open as needed. Because, for example, if you have a contact center or something like that, they will have one number which will need to be able to receive and establish many calls with that same one number. So this security profile obviously is not good for them. But the appropriate way to approach this is to lock everything, and then when they complain, give them more. It's not a problem to enable it for one. It's a small attack surface. But if you do it for everybody, somebody will breach it. And a minute on self-provisioning. So this is basically a web portal that enables you to configure your services. And expectation on vendor side is that when you have a system, that this web portal is something the telecom builds by itself. That it has its own look and feel, and that they build their own website, which then in the background talks to the vendor service. This costs money, this is slow, and typically you end up in a situation, let's just push something out so that it works, and later we'll put on something over it to make it, to brand it, to make it look nice and integrate into our systems. So what you get is a default vendor self-provisioning web portal. The issue with them is that they are usually basic in sense of security. They have locks for brute forcing, but they permanently lock the account, and there's no way to redistribute password without some integration on Telco side. They have no alarms. They have no validation if somebody is attacking them with some script or it's a browser. So it's basically something that's not really intended to be exposed on the internet, and often it is. Solution, the only thing I can think of is to put in an application firewall in front of it and simply parse out all the typical stuff, do some validation of the browser, two-factor authentication if you can manage it, but you probably won't have time. And there's nothing better to do until it's integrated into the proper system. Unified communication. So this is a telco attempt to have Viber or other services that offer some sort of sharing, file sharing, desktop sharing, and so on. And the risks here is that it's new. And obviously when something is new, you're more concerned with adding features than to implementing proper security. So basically monitoring is bad, you have no indications what's going on, it's hard to get information, you're being attacked, brute forced, scanned, and so on. And the particular issue is usernames, because telcos likes to use phone numbers as usernames, and they're guessable with dial plans. We've had several attacks from Russia, I think, where somebody was scanning our network for 3 days, trying to brute force accounts based on the dial plan of the country. And they lock all your accounts. So, when they do that, they pretty much lock up all their accounts and nothing is working, everything is locked, and you have a huge password distribution issue. This is what it looks like in high-level architecture overview. You have some services in DMZ, the voice is pushed through the voice services, and the only way to secure this is the same as the self-provisioning, is to put something smart in front of it and capture all the sessions and intercept all the traffic, decrypt it, analyze it, and try to detect when somebody is trying to breach you. Hopefully in a couple of years those systems will be better and maybe they will be able to stand alone on their own, but I'm skeptical from what I saw. Now this is a bit specific, so it's forking. Idea is as follows: you register one telephone and then you register the second telephone with the same SIP user and password, and basically when somebody calls, both the phone rings. So this is a simple way to have a service that allows you to have some sort of primitive hunt groups or so on. So it's cute, it's useful, but the issue is when somebody breaches your account and they register in parallel to you. They can listen into the calls you get, so they know what's going on, they know who's calling you, they can establish calls outside and not impair your service. So these kinds of attacks are a problem because nobody will complain. If the attacker is careful, he can exploit call on your account and nobody will complain. At least until they get the monthly bill and it's big. So the solution is to have separate identities. This is a real problem to implement. This is complicated. This is big. You need to have an application server to have services like hunts and so on. And it's expensive. But on a large scale, this is the only way to do it, because with forking, you're just waiting for trouble to happen, and you won't be able to tell that something was happening. There's not a lot more. So what to monitor? Everything. Wherever you can get info on something that's not the usual call flow, you should have some way to track it and to react to it. This means parsing SBC logs to see, or syslog messages, to see if something triggered, anything that doesn't trigger usually, any errors that are larger in quantity than normal. If you have a special system that taps all the signaling, bigger telecoms typically do, you can do the same thing on them, but usually it's hard to customize for specific cases. For example, if you have separate user IDs, like for forking, maybe you want to have a special rule for those users that come only from the internet because they are differently formatted. This is hard to do with tools like this because they are out-of-the-box type of things, but it's possible. Application servers, they have usually watermarks when something is coming in and it hits a limit, so those should be checked. And all of these so far were technical metrics for the system. But you also have fraud management. I initially wrote here anti-fraud, and I got many complaints from the guys. They prefer to be called fraud management. Basically, they also do the same thing. They monitor signaling, and if something looks off, like somebody spent 100 kunas last month and spent 100,000 kunas this month, they trigger. But they're slow, which is why you need to have all those stuff before to notice that something is going to happen. So, what would I like for you to take away from this talk? First, resilience. Whatever you have, it will fail, it will crash. You want to have everything segregated and locked. If you notice a bunch of traffic coming from Mrduša Donja, then you want to be able to block that whole town if need be, because you need to have your emergency services working, you need to have your rest of the network working, and you can sacrifice one small part until you figure out what exactly is going on. You need to have segregation for that to work. Not everything is equally important. When you wake up in the middle of the night because somebody is calling you because you have a ton of alarms and you figure out that all of the network is halted because there's some sort of attack, something is going wrong, it's not your first task to make everything work. Your first task is to make critical stuff work, which means you can afford to shut down not critical, which means that you have to go back to the segregation. If you have properly segregated your network, you can afford to shut down one small part to save the rest and then troubleshoot for a couple of hours. And the last one, you probably won't be the person to maintain it. So make it easy, make it simple, because if it's not easy, simple, understandable, somebody will disable it at some point because it's interfering. This is it for me. Are there any questions? Maybe it was a bit too much data.
And no questions? Okay, thank you. Thanks, Kosta. We will continue at 11 with Jelena about security in healthcare. So please come. You have 15 minutes. Listen. Thank you, Kosta.